I think only 100 can come in the Zoom link. So then I will post the YouTube link as well. Okay, then now we shall start. Venkat sir, shall we start now? Venkat sir?
Yeah, we can start. We can start.
Okay, sir. Okay, sir. Uma Nagalakshmi?
Yes, sister.
Okay, now you can start, ma.
Okay, sister. Today is not just another day. It's a new opportunity, another chance, a new beginning. Embrace it. A blessed and warm morning to one and all gathered for this invited talk on the application of physics in health science. A day without prayer is a day without blessing, and a life without prayer is a life without power. Now, let us all invoke God's blessing and gain power through this prayer. Prayer by Dr. Reverend Sister Jessie Fernando.
Let us all, for a few seconds, close our eyes and feel the presence of the heavenly God within us and around us, who is the guiding star in all our being and doing. Let us pray. All-powerful and ever-living God, we praise and thank you for this wonderful opportunity to expand our knowledge in physics. Bless the resource person, Mr. Pragadishwaran Venkat, with wisdom and knowledge to express his views clearly. Bless him with good health and mind to continue his service of sharing the knowledge gained. Grant him all his heart's desire, Lord, and bless all the young minds who are so eager to learn and explore new horizons in their lives. Thank you and praise you, God, for giving them the spirit to learn. Bless all of us connected here from various academic platforms so that we may be enriched and we may truly find the joy of knowing more and more of the hidden treasures of physics. Dear friends, let us for a few seconds, with one mind and heart, pray for the well-being of our people in India who are gripped with the fear of the pandemic. Once again, people are disturbed about the different forms of the pandemic. May the face of the earth be renewed by the compassionate grace of God all-powerful. May we realize the truth about life and live a life worthy of our being according to God's plan. May God give quick recovery to all those who are sick in body and mind. May we have strong faith in the good God and pray that these tough times too should pass away soon. May the peace of God remain with us all. Amen. Om Shanti.
Thank you, sister. I kindly request you all to switch on your cameras for the photo shoot session.
Excuse me, sister.
Yes, ma?
Sister, can you ask sir to stop sharing so that I can take the photo?
Sir, Venkat sir? I think he has stopped sharing.
Yes, sister. Thank you.
Yes. So students, kindly switch on your video.
Okay, participants, kindly switch on your videos. I have taken, sister.
Okay, ma. Thank you, ma. Thank you.
Welcome, sir.
Yeah. Now we request all of you to please switch off your video as well as your audio so that we will not have any bandwidth issues. Nagalakshmi?
A day without prayer is a day without blessing, and a life without prayer. Sorry. There is little in life so reassuring as a genuine welcome. May I now invite Dr. Eucharista Immaculate Sylvia, Associate Professor, Department of Physics, to welcome everyone and introduce the speaker.
Surround yourself with the dreamers and the doers, the believers and the thankers. But most of all, surround yourself with those who see greatness in every activity and in everybody. A very good morning to one and all connected in this virtual platform. I consider it my proud privilege to welcome the august gathering for interestingly waiting to hear from the eminent personality the fascinating facts about the applications of physics in health sciences from our resource person, Mr. Pragadishwaran Venkat, and the noble hearts responsible for such a great activity. Our resource person, Mr. Pragadishwaran Venkat, entrepreneur and founder director, Aries Biomed Technology Private Limited, Coimbatore, is a very active personality specialized in design and development of medical and healthcare products. Their capabilities include design investigation, research and concept development, rapid prototyping, technology transfer, and manufacturing. He obtained his diploma in electronics and communication, bachelor's degree in electronics communication engineering from Bardhasan University, Trichy, and MTech in biomedical instrumentation and signal processing. He has served as biomedical service engineer in Phoenix Medical Systems, Chennai, technical support engineer in research and development department, research and development engineer in Premier Evolvix, Coimbatore, and currently as research and development engineer, assistant manager in Tricol Medical Systems Private Limited, Coimbatore since July 2006. We are happy to have you amidst us, sir, and waiting to hear about the applications of physics in health sciences. On behalf of our management, staff, and students, I extend a very warm welcome to you, sir. Welcome you, sir.
Thank you, ma'am. I'll go for the session.
I'll just continue with my welcome address and then you can proceed, sir.
Yeah.
I take this opportunity to welcome our administrative superiors, our secretary, Reverend Sister Flora Mary, our principal, Dr. Reverend Sister Lucia Rose, our vice principal, Dr. Reverend Sister Kolande Teres, our Star College program coordinator, Dr. Sister Janosius Alphonse, and all other heads of various academic sectors. I also extend a cordial welcome to the participants from other institutions. It's my pleasure to welcome the staff and students of my own institution. Once again, I welcome one and all gathered and wish and greet that we receive valuable inputs as much great as we can from this resource person. Welcome again. Over to Uma.
Thank you, ma'am, for your warm-hearted welcome. Tell me and I forget. Teach me and I remember. Involve me and I learn. Now, I hand over the session to the resource person of the day, Mr. Pragdishwaran Venkat, entrepreneur and founder director, Aries Biomed Technology Private Limited, Coimbatore, India. We are waiting to hear from you, sir.
Thank you. Good morning, one and all. Myself, Pragdishwaran Venkat, myself, founder director of Aries Biomed Technology, Coimbatore. Already it has got some kind of a delay, so we'll go for the session directly. I hope my presentation is visible to you all and my voice is audible to you all, very clear, right?
Yes, sir. Yes, sir.
Yeah. Is there any interruption? You can actually put it in a chat window so that I can stop, look for any problem in case, right? So we'll go for the session. So the session is going to be like this. So, ma'am?
You can switch on your video, sir.
No issues, no issues. Maybe a bandwidth issue. I don't want to switch on now. My presentation is fine. I think so, right?
Okay, sir.
End of the session, I'll switch on for the question answer session, right?
Okay, sir.
Okay. So the presentation is going to be like this, right? Introduction about my company, about my products, and simple presentation about it. And we are going to see the physics discoveries, the people who sow the seed for the current today's the technology that we are utilizing, right? Our forefathers who 150 years before it's all started. So we are into a very modern medical science. It's all happened because of physics, right? Even engineering is overall, if you take it up, is nothing but physics, right? Complete any discipline you take it up, whether it's a chemical engineering or a civil engineering or electronics engineering, everything behind the backbone is physics, right? Especially physics contributed a lot for medical science, especially on radiology. Medical, we categorize in multiple segments, monitoring segments, ambulatory segments, home segment. In that monitoring, radiology, and orthopedics, so many things, right? So in that, physics contributed very high-end contributions towards the radiology. And that is what we are going to see. What does that people 150 years before they gave us, that is what we are here. We are just to explore that. We are not nothing. We are here to invent something new. It is all our forefathers, the great scientists. They come out with the solutions for this world. That is what we are actually using it, and actually, right? So we are going to see a very crisp presentation on physics discoveries. And then we also, Aries Biomed Technology, come out with some kind of a innovation with the help of physics. Very recently, we had some kind of a research after the COVID. We come out with a product which is actually completely speaks about the physics, the pure innovation physics. So that also I wanted to explain. And also I would like to introduce some of the tools for the kids to explore for the application with respect to the software side of it. Obviously, without software today, we can't do anything, right? So we are most of the time we are spending time with computers, with the help of computers, at least in the laboratories. So I would like to introduce some of the free open source tools for the physics students, especially to explore it on a medical area, right? And also to introduce few gadgets, the students to explore. Very few gadgets I got to understand. It's very few. So that is what the overall session is going to be all about. So let us go with the session. So Ares Biotechnology, basically an innovation product company. I started this company in 2010, and 2015 we registered this company as a private limited company. We come out with a product solutions. It is of no usual case of products. The problem in India is like medical equipments is like 80% of the equipment we are importing only. Only 20% of the equipment is we are indigenously manufacturing in India. In 20%, if you take it up, 10% of the equipment is mostly related to mechanical oriented products, where it requires a huge space and weight to occupy to import. So we forced to do certain manufacturing like a hospital bed kind of products in India. Rest of the 10% are the only companies in India who are doing a niche product development. If you take any big companies like a Reliance or a Mahindra or a Tata, you name any big companies, they are not into medical equipment technology. The problem here is because of a lot of restrictions on the patents, as well as it is a very niche technology area is requirement. So we are evolving. Obviously, we are seeing that 80% is an opportunity. It is with our students' hand, right? The young generation hand, where we can actually come out. We are very fastly catching up with the market compared to the the world GDP. Our contribution towards the medical equipment market is very small, but we are soon catching up, and we Indians working on very niche technologies. Like in Coimbatore itself, if you take it up, one company, Surabhi Biomedical, I would like to mention very specifically here. They are into ultrasound manufacturing, indigenous ultrasound manufacturing. They are coming out with a very low-cost ultrasound. And Stan Biomedical is one of the very renowned medical company who are into medical hospital gadgets. And we are one of the company who are into very niche biomedical products. One speciality with our product is like we are the first company in India to come out with products for biomedical engineering. Obviously, there are companies in India, many companies in India who are into biomedical products for the hospital doctors end use. We are also into that, but we are also into the gadgets required for biomedical engineers to use. We are the first company in India who are coming out with the gadgets for biomedical engineers in use. So this is some of the products I displayed here. This is all our initial range of products. We are coming out with anesthesia ventilator and a warfield ventilator for a defense, and a biomedical toolkit, biomedical kit. This is a biomedical kit for the biomedical engineers with the first kind of product, and a flow analyzer kind of products for the Indian market. And we are continue to thrive in this field with the new innovations. This is a crisp introduction about our thing, and we will later on see what is the innovation we are carried out, and we launched a product recently into the market. This is our team. We have a production and R&D office, 2 offices in Coimbatore. We are into biomedical product development. That is actually our team comprises of biomedical and software engineer, embedded software engineer, application software engineer, and modeling and simulation engineers, electronics design and development engineers, and production side of it, people who are into quality control and assembly, storekeeping, and logistics management. So this is our small setup in Coimbatore. We have 2 offices at Coimbatore. Okay, let us go with the session. Okay, so we will first go to see like the physics discoveries, where it's all started in 1895, almost like 126 years before, with Dr. Runyon, who's the person, he accidentally introduced X-ray into X-ray by, he's basically a physics scientist. He introduced X-ray, right? By accidentally, his experimentation took up his wife's hand. After he developed the film, he got actually accidentally the internal skeleton structure of the hand. Okay, so that is all where it started. He is the person who received the first Nobel Prize in physics. So that is what I said, the contribution of physics towards the health science, the first Nobel Prize gone to this particular innovation, which is actually contributed to the health science. And after that, X-ray is currently used in many places, even in airports, military applications, and even in construction industries, and much more actually. But the first thing, the image is coming out of a human hand, right? So that is the greatest thing which has happened in 1895. It is a very breakthrough innovation. Still date, nobody changed the basics of X-ray. The contribution of X-ray is great, and still date, the first day in 1895, what is started, and today still we are using the same technology with a modified, picturization, storage, and reproduction. That is what is changed, but the basics physics concept is never changed actually. So this is a very impressive contribution by the physics, at the first, and this is where this all started. And the next thing is Dr. J.J. Thomson, who introduced the electron tube, which contributes to other industries like television industries and much more of instrumentation industries. Oscilloscopes coming out with this particular technology, televisions coming out with this particular technology after the discovery of electron, and it took up much more of shape, right? It all happened in 1897. The next is Henry Becquerel, who actually introduced natural radioactive material, very initial radioactive material. Then his disciple, his students, Dr. Marie Curie, she sacrificed her life with her husband, and you all know very well, right? She sacrificed her life in the experiment, and they come out with the radioactive materials for cancer reduction and much more. This particular technology also is still date is in use for cancer therapy, and even with the modern PET nuclear imaging, this particular technology is only used. See, none of this technology is outdated. Still, from the X-ray, from electron tubes, everything is still in use with very modern, sophisticated monitors and other stuff, right? So these people are very great. Who's Mr. Henry Becquerel, who actually come out with the natural radioactive material in 1896, and he's also got a Nobel Prize. And very interesting, very interesting, Ernest Lawrence, who invents the cyclotron. Currently, cyclotron, magnetron, and so many innovations is an application with the micro one to the MRI machines. But compared to all other people, this particular fellow, Dr. Ernest Lawrence, who come out with the cyclotron, which consists of very high field magnetic components, which is the natural magnets being used. It is a very basic innovations for the current modern MRI machines. And if you see his laboratories in Google, you just explore in Google his innovation machines. Like you can get a feel of seeing science fiction movies where it has got a very big machineries with lot of tubes and pneumatics, hydraulics tubes with the electrical connections. It's a very weird kind of laboratories used to have, and I could say that he's a very very typical person. So far, I haven't seen a kind of person. You born into this world. Actually, his laboratories are totally different, right? And you can see a very big machines with a very big magnetic fields around, and he's a father of cyclotron kind of magnetic based physics machines, right? So and his contribution was very big. And Dr. James Chadwick, who's we used to call him father of nuclear physics, right? He's a person who invented the neutrons, and his innovations contributed towards the MRI was great. And it is also not only for MRI, is also for nuclear medicine, right? And he's the first person who introduced the neutron particle. He is a person who declared neutron particle to the world. And obviously we call him, right, he's a father of nuclear medicine and nuclear physics. And because of his innovations with the neutron, still there are much more physics experiments is going on with neutrons and extraction of neutrons. And complete MRI is actually working on his principle of how we are actually spinning the neutrons during the photography, right? During the imaging from the MRI, magnetic resonance imaging. And this particular innovation contributed not only to medical innovations, is also for nuclear science and space technologies and much more, right? And you can see Mr. Dr. Felix Bloch and Edward, who actually the father of NMR, nuclear medical resonance imaging, the modern cancer detection to the brain tumor detection, you name anything, with the help of NMR, nuclear medicine, magnetic resonance imaging, is contributed by these two gentlemen. I also admire, like, the person Felix Bloch could be a Hollywood hero. He looks very handsome, right? I always admire that. But he didn't, he didn't gone to Hollywood. Thank God. Actually, he came to nuclear medicine, and his contribution still today helped us to develop the very modern nuclear medicinal approaches. And these are all our people, we must thank. Today, we are all gathered here. We must thank to all these people, and much more people are behind. Not only these the set of people, but they are all very great scientists, and they are followers. They are followers in the sense the people who contributed based on their base paper. Much more people contributed, right? But whatever we are seeing with respect to the modern medical sciences, the techniques of radiology imaging, radiology, whatever we call it as radiology, that is what, physics is everywhere. Physics is into civil, physics is into chemical engineering, physics is into electronics engineering, etc., etc. But first of all, we are all here to thank all these people, and we actually, the contribution towards the radiology is such a great with the help of physics, right? And if you see the technology of evaluation, the radiology is a very basic thing, started all from X-rays. It's basically utilizing the principle called absorption, which helps to capture the very basic imaging. The beauty of X-rays is still, I'm as a biomedical engineer, I used to admire is, it's a very low cost, till date it is very low cost. All that you need only a X-ray generation tube and a dosing controller and the imaging output, that's it. Still, any small hospital, with the help of with a 1 lakh or 1.5 lakh rupees, they'll be able to get one X-ray imager, and that is helpful from animal husbandry and dental area and very high advanced thoracic examination. Today's, after COVID, the X-ray is becoming very popular. wherever people suspecting that lung damages, right, they ask people to take X-ray images. See, it's all invented 126 years before. So it uses a simple absorption technique, and still date it is used. Very admirable technology. And echography. Echography, it is used on a reflection transmission technology, which is we used to call it as ultrasound technology. Ultrasound technology is a very non-invasive method. Obviously, X-ray has got some kind of invasive in nature. Invasive in the sense, in medical, we used to call two types of invasive. Invasive in the sense, whatever a medical practitioner is actually intervene by using either a knife or using some other tool to invasively examine by opening the body part. That is also invasive. By exposing the body into a harmful radiation is also kind of a invasive, right? So this X-ray is got some kind of a dosing radioactive rays to be passed through the object. So it is kind of little dangerous thing. But when after the invention of ultrasound imaging, it is 100% safe, even to use it on a patient with a pregnancy. People examining the growth of a baby without exposing them into X-ray kind of harmful radiations. And the beauty of ultrasound imaging is also like it gives you a functional imaging. We always call it as functional imaging and static imaging. The X-ray is a static imaging where one two-dimensional view we can get it. This is a two-dimensional view where for a baby they can actually found the baby's movements and its growth and can be videographed. Okay, so the Doppler imaging, right? So this is echography. It is all invented in 1950s. And nuclear medicine. Nuclear medicine uses a gamma rays, and it's a radiation emission which completely explore the body for even a very small tumor growth in the body part. So it is we call it as radioisotope imaging. It is all developed after 1950s. And X-ray computer tomography. X-ray computer tomography, we call it as CT tomography, CT imaging. That is a combination of X-ray with a computer. That is basically we used to call two ways: computerized tomography or computed tomography. See, X-ray is the problem with the X-ray is it is a two-dimensional output. For certain cases, when they do an operation on a patient, they wanted to find out without actually completely opening up the body part. They wanted to find out the passage of fluid or passage of inserting a needle or a catheter, not we call it as needle, a catheter into a body part to do a morphology. Morphology means what they do is like it is a two-dimensional view taken in a multiple angles, and then it will be morphology over the imaging, and it will be present to a doctor as a functional computerized X-ray image, so that they can actually find easily where the catheter goes, where the passages they are actually exploring during the anything like heart surgery or orthopedic surgery or a brain tumor surgery without opening a complete thing. The problem with MRI, right? The certain cases, MRI gives you a better morphology and functional image with respect to CT. But the problem with certain operation theaters, they cannot use MRI. MRI, the problem is like during MRI image function, doctors cannot use any instrument, because MRI basically gives you a very, very clear spatial information of the brain or any body part, except bone classification. The bone classification, obviously, that requires the X-ray. So CT is must. Anything related to spatial internal morphology, MRI is the best. Very high resolution images it used to come out. Any cancer detection, anything, that is the best. The problem with MRI is people in emergency, people who are into ventilation kind of a thing during the operation, they cannot use it on a MRI. MRI basically uses a high magnetic field environment. They choose to have a static magnet. On static magnet, patient is lied over. So what happens is it's all actually makes the nitrogen or particle of the body to excited. By spinning the nitrogen particles, they are taking the image out. But the problem here is they cannot use even a small scalpel, right? It attracts. It's very dangerous to use it along with the MRI. But functional morphology MRI is used to find out the very smaller tumors present in the brain or any part of the body, right? So this is the two important things, right? X-rays and radio waves. X-rays are multiple uses along with a CT in operation theaters. During the morphology in the operation theater, they can actually do an operation along with the functional computerized tomography. Magnetic resonance imaging, where it is required to find very, very smallest spatial informations, morphological informations with respect to any kind of a tumor, and with the help of PET, this is positron emission tomography in combination with CT. Okay, so this put together, positron emission tomography is basically a therapy system. Okay, so this is not only a imaging system, it's also a radiation emission with a gamma rays along with the X-ray, like very similar to CT, but not exactly CT, to destroy a tumor in a very precise manner, right? So because the problem when they do with respect to the MRI tumor destruction in the cancer therapy, finding a small tumor is fine, but they have to destroy it. Okay, so they have to target in 2 micrometer size of a tumor is very difficult, right? So they use PET and they exactly focus to the 2 micrometer small tissue. There is a growth, abnormal growth, and destroy with the PET. That is why PET images are very rare in the country. Like in Coimbatore, if you take only 2 places, PET is there. I think 2 places. Yeah, one in GKNM and one in KMCH, right? And oncology, most of the oncology places, they used to have PET. And another problem with the PET is they use a very special kind of a excited one kind of a material to excite the that particular race into the for application of oncology. That needs to be prepared and used within 2 hours, within 2 to 3 hours, right? So once they fix the surgery, a particular thing has to come from Bombay. They'll catch up the flight. They'll fix the operation or the surgery according to that. They will bring it to Coimbatore. I have seen in direct, and that it will rush to the hospital. They use it within 2 hours because the decay period is very, very small. Decay period is very, very small, and one dose of that particular thing comes close around 36,000 or something. That is a kind of a very critical thing. So one is PET is very costly. That is CT is, you can see computed tomography in every hospital, most of the hospital, whether they do a operation, whether they do orthopedic surgeries. Most of the 90% of ortho hospital, they used to have CT. And 95, 99, 100% of the hospital, those who are doing cardiac surgery, they used to have CT, right? Computed tomography is, you can find it everywhere. Okay, it's like everywhere, right? But MRI, you can find in very 10 in 3 hospital, 10 in 4 hospital. And PET along with the CT, you can only find out 1 in 10 or very rare. Okay, so wherever they do a oncology related treatment, where you can find the PET, right? Very rare. That is why in India, oncology, that is especially cancer treatment, is very costly. Not only costly, is very complicated. There are very few expertise are there to handle this PET, and it is very dangerous exposure even for the people who are into treatment. We must respect our doctors, the people who are into oncology. Many doctors, even you must have heard Dr. Recently, Batmashri, Dr. Sharada madam, who got into cancer and she died because of the cancer. She is very famous oncologist. You all very well know about it. Then most of the oncologists, they die because of cancer treatment, during cancer treatment. So this is very critical area, right? So, okay. So what image you are finding here, I'll just give you some kind of a spatial information about the different images. So sagittal and coronal informations about the simple 2D X-ray output of a human body, that lung output, lung image is a very simple X-ray output. This is computerized tomography. See here, this is a very, very early CT image when they started with this. The current technology is well advanced and it is functional, and it is also colorful. They can actually find a very tumor in a very different colors. That is why every year, right? Every year when doctor seats are getting filled, the first and foremost seats getting filled in a doctor discipline is radiology. Almost like 20 years before, people rarely take radiology. They don't give much more importance to take radiology discipline. But it's all changed very recently, and the first and foremost people, all the seats of radiology will get filled up. The demand for radiology doctors are very high because, whether it's a respiratory medicine or it is a oncology medicine or it is a cardiac medicine, the opinion from the radiologist is taken as a very first prioritize suggestion, right? Because every doctor cannot examine the radiology image. It's very complicated. First and foremost, once that image is being taken, that will be given to a radiologist to consult and take an opinion from the radiologist. Then the expert doctor, whether he's an oncologist, most of the oncology doctors are radiologists. But other discipline doctors, they wait for the radiology doctor to give an opinion. Okay, so that is an expert opinion. Okay, so this is a very important discipline. Even I am telling you, all you physics BSc students, you people can become a radiologist. How? Because you know physics. That is the beauty of it. Once you know physics, you are eligible to do radiology there is courses available, expert radiology courses where people can be a laboratory radiologist, may not be a doctor, very similar to a biomedical kind of a stuff, who can give a suggestion to a doctor based on the image output, right? That's, they examine the image and they can give a suggestion. You can see in every scanning centers, private scanning centers, there are multiple private scanning centers in Coimbatore itself, I could say that. I don't know about Thoothukudi, I'm very sorry. And multiple of places where private scanning centers are there. Every hospital requires a radiologist. So people can learn radiology as a separate discipline. That is what I try to stress here, right? So it's a very interesting thing. And this one is a computerized CT functional image of a body. That is actually this images with respect to cardiothoracic output, inhalation and exhalation of the body. That is, this is a computer TCT output. Each and every small movement of a thoracic diaphragm is imaged and presented to a doctor. So this is CT, and this is CT combined with the PET. This is CT and this is PET combined to give a very perfect image output to say, is there a tumor present? Not only tumor, it is PET is very interesting. Actually, PET is not only tumor, it is also will help people to understand the Parkinson's disease, the development of Parkinson's disease. Say example, here you see like is a normal subject, is a brain image with the help of PET. Only by inserting the special liquid, what I said, right? That is what it gives you, this colorful functional output of a PET, which tells doctor like how his brain responds, how fast it responds with a compared to the normal human study and people who got a Parkinson's disease or development of Parkinson's disease or development after the treatment of Parkinson's disease. So this is what it is. So okay, then okay, see, anything you take, any radiology instrument except X-ray, it's all very costly, right? But I would like to present one of the case here. This particular device, it's an ultra low field brain MRI scanner. It is invented by it is not invented, we can say like it's re-engineered by one of the Brazilian students. Because basically MRI is very costly equipment, very costly equipment. One MRI device, that new MRI device comes close to around 14 crore. One Toshiba, one new thing. And so basically in India, mostly we are using a MRI which is a used one. That is it's a refurbished one, mostly in hospital they use. So this particular thing is re-engineered and it's actually application-oriented device. It's not just a prototype. They used it, but it is a very ultra-low field brain MRI scanner, which works on a normal 220 volts, 15 volt socket supply. And this has got a very basic construction, which has got an internal magnet and a small imaging system to capture data and then use it for interpretation. That is, see, this device I wanted to present here because, you know, you students can do such kind of things, right? Obviously, any radiology instruments are very costly, X-ray, except X-ray. X-ray itself is, X-ray tubes are very dangerous to handle and all that. It is all there actually, right? But a dental X-ray, you can actually buy a dental X-ray for 50,000 rupees from the market to do a small object classification. All right, and this is, you see, like this, it's all very poor college students. Now I cannot say very poor, I'm very sorry to use that word. Normal student, college students, they actually built this particular ultra low field brain MRI scanner. Okay, what is the latest thing in radiology? Okay, we have seen what is at the developments, what is the difference between the CT, MRI, and PET scanners, and what is very latest? The latest is focused ultrasound. This is where the current physics is concentrating on, because the focused ultrasound, it's again ultrasound in a very precise manner. Because the basic problem with ultrasound is actually the spatial coverage is, at least it requires 2 inches of a probe. Okay, so there are very smaller probe to will penetrate inside to capture any small changes in the heartbeat of a fetus of the mother, and also it's very sharp ultrasound, but the output from the ultrasound is very small. But currently people are experimenting on focused ultrasound, which gives you more informations with respect to the cell level interpretation of data without exposing the harmful radiation like X-ray. That is the beauty of it. Okay, not only that, ultrasound is cheaper. It is functional. It is less harmful. It is actually it's less invasive or zero invasive, right? As many as time can be exposed even to a pregnant person, right? So that is all the advantages with ultrasound. So the ultrasound physics are more concentrating on ultrasound, especially on focused ultrasound, to mostly replace how they can actually replace certain areas of harmful effect of CT combined X-ray, this one. So this is not only for brain investigation, it is also for mammography, right? Because the breast cancer is the highest problem in the oncology currently, especially in India, right? So currently the mammograms are used the partial X-rays only, right? So they are to examine abnormal growth of a tissue or something, the tumor of a breast. So they'll try to use focused ultrasound. Okay, so anything you students wants to focus towards, to get explore. I wanted to do something on a new thing. You also try to do something on a focused ultrasound. You can just explore it. What is focused ultrasound? What it allows? Whether we can do something in India to work on, because very few people are working on focused ultrasound. If you're taking up anything on a future for PhD or a doctorate, just take it up focused ultrasound. If you're very good at physics, just close your eyes, start to work on focused ultrasound. Definitely, it has got a huge future in this. Okay, let us come to Aries. What is our small innovations in physics with our devices? Basically, that is always I used to say, see, we have seen people, our great people, our forefathers who invented the great physics. They gave in a golden plate to us. Because of them, by God grace, we are using that, and we are living a very quality life. Apart from the huge population and all this, we are living quality life because of the great physics invented by them. And we must also contribute, we must also try something to that. So with small taken from the physics, we also come out with a small solution, right? That is what I'm going to explore that, give you that. Actually, this is the high flow device. See, after COVID start, right? People on respiratory devices, basically 2015 itself, our company, we registered as a respiratory related product company. And we have given a lot of innovations with respect to Warfield ventilators for defense electromedical laboratories to develop a Warfield ventilators and all that. So in current scenario, the high flow devices basically blends oxygen along with the air. Okay, so that is electronics based. Basically, it has got a turbine. Internally, it has got a turbine which sucks air from the atmosphere, and it sucks also the low flow oxygen inserted into the system, humidified it, and then supplied to the patient. This is our first device, high flow electronics device. But we experimented in 2020 mid to start innovation on a physics without using turbine. We wanted to solve three problems. One is we don't want to use power supply, because basically the turbine based system requires import. The turbine need to be come from Korea or China. We don't want to avoid that. The second thing is we don't want the device to be used with the power, because if the device to be used on an ambulatory, we don't want to use the ambulatory system to use the power, right? And also to save oxygen. And also the fourth thing is not only to generate high flow, also to blend oxygen, also to generate CPAP pressure. In a basic turbine-based system, it cannot do a CPAP pressure on a high flow device. So we come out with the Venturi adapter. It's a very Venturi capsule we developed with the 5-axis CNC. Basically, it uses the Venturi. You all physics students must have very familiar with what is Venturi, right? Venturi is basically a air amplification system which makes anything a fluid or air to get, when it gets into high pressure, this will get multiplied with respect to the flow, and it also sucks the air from the atmosphere and blend it. Okay, so this is the system what we conceptualized and we presented to Indian government. We got a sanction on the project and we developed a Venturi capsule. Basically, it is powered with the oxygen supply. It doesn't require any power supply to generate high flow. It's powered with the high flow oxygen, high pressure oxygen supply, which takes the air inlet from the atmosphere to blend oxygen, where oxygen percentage in the flow will be adjusted, only 2 knobs. And with the electronics, we monitor what is the flow which goes to the patient with the blended oxygen FiO2 monitor on ultrasound, and it goes to the patient. This is what the first prototype we come out with in 2000, second wave, first prototype to Bayrak. And we actually, this is a Venturi capsule which is powered by the high pressure inlet, and it has got only 2 knobs. This basically uses a 5-axis CNC, and it's a complicated system, right? So and it supplies oxygen. This is a very basic system first we developed. The advantage is here it doesn't require power, and it goes up to 2 to 60 liters per minute. With the blended oxygen, 30% to 100% can be varied, and it saves oxygen in 30%, and it is also a CPAP generator. Okay, so this is combined with the basic monitor what we had, and we come out with the very latest equipment we deployed currently into the market. And this is our latest thing with the same technology we used with the modern monitoring system to monitor multiple parameters like peak inspiratory pressure, FiO2, and oxygen consumption calculators, and with the humidifier it is supplying to the patient. This is a very typical thing which I would like to express in a small company like us, with the interest, with the understanding of physics. We also come out with a small solution to the market. Likewise, around us, the physics concept are existing. There are a lot of problems existing out there where students can, with your interest, basically it's all need your interest, basically to fire in the belly to do something, right? So we can actually to come out with a lot of this kind of innovations. We are all currently working towards Venturi-based ventilator without air supply, only to work on oxygen. We are working for Venturi-based ventilator. Currently, it is an R&D. We are going to come out with the first Indian Venturi-based ventilator, and also Venturi-based BiPAP therapy. So this is all is in our R&D cycle. I also introduced some of the physics experiments, because basically we all explore a lot of open source tools available in the market, because Certainly, there are math models like MATLABs are very costly, right? Or company like very small companies, we are not afford to do that. Use it. So MATLAB kind of tools. There are very high powerful tools. People from UK and people from abroad, US people, they explore a lot of things into the market, which is all basically works basically on a Linux platform. Most of the things works on a Linux platform as well as in Windows platform, some of the tools. These are all the tools. You note it down. I'll send the presentation across to you, which you people can explore. If you are using on a thermodynamics, or if you are using it on a astrophysics, or you are doing anything on a any kind of fluidic experimentation, you can do a simulation, you can do a math model, creating a kind of a math model to prove your concept in a first level, right? You as a student level, you must be aware of MATLAB. Is a mathematical tool software, very famous. COMSOL, COMSOL, COMSOL. COMSOL is a very paid one. It is a very costly one, and it is very affordable price for the student. But apart from that, I also wanted you people to explore on Root, which is a modular scientific software framework for the physics experimentations. Octopus, which is a scientific program not only for physics, is also for a bit of chemical kind of experimentation and exploring load related problems. And STEP is actually a physics simulator, which comprises of multiple things, like multiple things. And flow solver is anything which is related to fluidic flows or differential equations solving and all that. And Pythia is basically a Python based physics event generator. I also would like to stress you people to explore, definitely, whether you are exploring other tools or not, you people definitely explore these two tools, right? One is processing. Processing is a Java-based platform. It works on any platform, Linux or Windows, any platform. You please download processing and run all the examples. Run all the examples. You will get excited. You will just really get excited. The programs are very straightforward. It is actually, currently you all must heard about Arduino platform, the same platform they used, Java platform, right? So you please go ahead to download processing software and explore it. Just explore all the examples of processing software. You will be getting addicted to it. And if you are a programming geek, if you are a programming kind of, if you like programming, you start loving processing and start to use the processing on experimentation and lab level experiments. And also Skylab is a free open source replacement of MATLAB, which gives you all kind of visual as well as a Skylab. Simulink like kind of a platform is also there in the Skylab, which is completely open source and free, where you can get it, explore with all sort of experiments with this Skylab. I request you to explore processing and Skylab, and you will really get addicted to it. And obviously, people can to start to do some kind of modeling. This is one kind of a simple model. Maybe your lab also may be having a lung experiment model, which you can create by using a small bottle balloon experiment, right? So these kind of things, this kind of a small gadgets, you start to explore in your laboratory for a physics experiment for the health sciences. You all very aware about this, right? $1 microscope. It is available in Amazon for less than 1,000 rupees. Where you can see a very smallest microparticles, that is bacteria, by using this $1 microscope. It's called $1 microscope, but in India it is costing close around 500 rupees, but it's still interesting. I purchased for my kids, and they are doing very good fun using this. Very nice it is. These are all you may know, right? This just I'm just suggesting with a very small my knowledge. So I'm open to questions. I'm ending the session here. I'm open to question. If you got any question, you may please ask me. See, I'm not a physics expert like your professors. I'm an electronics expert and a biomedical expert. I cannot say expert. I know something biomedical. I know a bit about, with my small experience in 20 years in biomedical and electronics. I can try to answer your question. If you got any question, please ask. If I know something, I'll try to share my knowledge. Thank you.
Thank you, sir, for a remarkable and exceptional session. Now, the platform is open for discussion. Participants can raise your questions orally or through the chat box to get your doubts clarified.
Students, kindly come out with your doubts. Sir is very eager to answer you. Or you can even type in the chat box. Sir, in your company, sir, are you manufacturing any of these COVID test kits?
No, actually, that is more of a pharmaceutical products, right?
Okay.
We are not doing anything related to COVID test products. We are obviously manufacturing ventilators and high flow systems for COVID care. Our products, we also have oxygen conservation device. It's again a new innovation which conserves oxygen on 1:4 ratio on oxygen cylinder, which is a completely electronics piezo valve based system, and that is into market. We are not into COVID test kits.
Okay, sir. Thank you, sir.
Yeah.
So I think nobody has any queries. It's very clear. So students, the attendance cum feedback form is posted in the chat box. You please fill it before you leave.
Can I conclude the session?
Yes, sir. We shall finish up with the vote of thanks, sir.
Okay, so thanks for everybody patiently listen my presentation. Obviously, physics itself is a bit of a heavy subject, complicated and heavy subject. Thanks to your professors, obviously, who takes as a theory. I can say something in an image, and I can put some image. I can talk about it for another 1 hour, not a problem. But approaching it in a very theoretical manner is very difficult. Only professors can do it, actually. So I respect all you professors who gave, I also trained by the professors, right? So because we have innovations, we have company, we have products, it's all because of professor who gave us knowledge to us. And thanks to all. And it is a very small insight. I hope I gave a very small insight about related to radiology and physics application in radiology. But apart from radiology, the time is very constrained. It is apart from radiology, there is another big area to explore in the physics is optics. Optics is a very big area, right? If possible, I have one more friend of mine, Mr. Shajan, who's very good in optics related in physics on biomedical application area, who have done some of the products. If possible, I'll try to connect them in the future. It is another big area, right? So thanks for the opportunity, which I shared some of my small knowledge here. Thanks to everybody. Thank you.
Thank you, sir. And sir, you can just contact your friend, and because we are very much interested in optics, and it's a major subject for us, no? So
Sure.
we can have a talk with him as well.
Sure, ma'am. Sure. I'll connect them.
Thank you.
Thank you.
Gratitude is not only the greatest of virtues, but the parent of all others. I now invite Dr. Reverend Sister Jessie Fernando, Head and Associate Professor, Department of Physics, to render a Sister, your mic is on mute, sister.
Now is it okay?
Yes, sister.
Okay. You can hear me? No?
Yes, sister.
Suddenly, I'm sorry. I'm very sorry. I think I got disconnected. So, sir, thank you very much. You have very clearly explained the various medical gaps, the students in the future, and learn more about it. And you have also made us realize the importance of radiology, the focused ultrasound, other physics-based fields. And I'm sure we are now understanding the importance of the medical role they play in, and how much priority is given to the views of the radiologist and all that. And also you have helped our students in knowing about some useful and interesting open source tools. I thank you, sir, on behalf of Marian Star Center, Department of Physics, for the useful lecture. I take this opportunity to thank our principal, Dr. Sister Lucia Rose, for being with us and rendering all the support in all our initiatives. I thank the Secretary, Reverend Sister Flora Mary, for her continuous guidance and blessings. I thank all the administrative heads of our college for their encouragement and moral support. I wish to place on record my sincere thanks to the Department of Biotechnology, Ministry of Science and Technology, New Delhi, for all the financial support to conduct this program. I thank the overall coordinator, Dr. Sister Genesius, for her support and guidance. Last but not the least, I thank all my department colleagues for sharing the responsibilities for the smooth conduct of this program. I also thank Dr. Jennifer, the Department of Botany, for being with us to give us the technical support. I thank all the participants, students from various colleges, faculty members, well-wishers for being connected with us, showing your keen interest to learn new things. Once again, I thank one and all connected here. Thank you very much.
Thank you.
Thank you, sister, for your warm and kind gratitude.
So thank you, everyone. So now I think if you have filled the feedback form, you can leave. We shall now call it a day. You leave, the students please leave only after filling the feedback cum attendance form.